9.5, solving quadratic equations using the quadratic formula. So the quadratic formula is the last method I'm going to teach you on how you can solve a quadratic equation. And remember, a quadratic equation has an x squared in it. Okay, so far we've learned how to factor these types of equations. We've learned how to solve by taking the square root. We've learned that if you graph them, the x-intercepts are your solutions. We've also learned that we can complete the square. Now I'm going to teach you what the quadratic formula is so you could use that. Quadratic formula works all the time on any quadratic equation to get the answer. Some of you might think, well, why didn't we learn this at the very beginning? It's not always the fastest method, although it works every time. And it's not all, I wanted you to learn the other methods as well and apply those. So quadratic formula would be this. We have x, which are your solutions, equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if you're like, what are these a, b's, and c's? Well, remember, in your standard form, ax squared plus bx plus c is equal to y. When you use the quadratic formula, we're not going to have it equal to y. We are going to set it equal, though, to 0. The other thing we're going to address in these notes are the discriminant. The discriminant is the radicand in this formula. So it's just going to be b squared minus 4ac. And the discriminant is used to tell you how many solutions there are. Okay, so let's apply the quadratic formula to this equation. Ax squared plus bx plus c is equal to 0. So I just put it underneath the equation because that'll tell us that our a is 2, our b is -5, and c is 3. So let's write that on the side. A is 2, b is -5, and c is 3. So x is equal to the opposite of b. The opposite of -5 is +5, plus or minus the square root of b squared, -5 squared, minus 4 times ac. So a is 2 and c is 3. All over 2a, which is 2 times 2. So we have 5 plus or minus the square root of -5 squared is 25, minus 4 times 2 is 8, times 3 is 24, all over 4. Okay, let's keep simplifying. 5 plus or minus the square root, and your radicand would be 1. 25 minus 24 is 1, all over 4. And then we get 5 plus or minus the square root of 1 is 1, over 4. Okay, so to finally get your last two answers, you do 5 plus 1 over 4 and 5 minus 1 over 4. This gives you 6/4, which simplifies. Always simplify your fractions. That simplifies to 3/2, and this simplifies to 4 over 4, which is 1. And those are your two solutions. For part B, it says on your own, but I'm not going to do on your own because I want to bring up something. So our a in this equation is -3, our b is 2, and our c is 7. So it says solve -3x squared plus 2x plus 7 equals 0 using the quadratic formula. Round your solution to the nearest tenth. Okay, so x equals the opposite of b, so -2, plus or minus the square root of b squared, 2 squared, minus 4ac. 4 times -3 times 7, all over 2a, 2 times -3. So we have -2 plus or minus the square root of 2 squared is 4, and I want you to make note. We have minus, and then these three numbers multiplied together would give you a negative number because there's one negative sign. So if you have minus a negative, that turns into plus. So I like to write my plus sign right away. So 4 plus 4 times 3 is 12, times 7 is 84, all over -6. So we have negative 2 plus or minus the square root of 88 all over negative 6. Because they tell you to round to the nearest tenth, you can just do negative 2 plus root 88 over negative 6 and negative 2 minus root 88 over negative 6. Please, please, please. You will get the wrong answer if you don't follow these directions, so please pay attention. When you put this into your calculator, one of two things you need to do. If you're just going to throw the whole thing into a calculator, you must put parentheses around negative 2 plus root 88, so around your numerator. And the reason being is because if you do not do that, the calculator will follow PEMDAS, and they'll do the division first. So they'll do this first and then add negative 2. That's not what we want. So let's put this into our calculator. So I told you can do in parentheses negative 2 plus root 88 divided by negative 6. And you end up getting, when we round, negative 1 and 2/10. Another way, if you don't want to put the parentheses around it, you could put it into your calculator. Let's do the next answer. Negative 2 minus root 88, and then you must press the equal sign and then divide by negative 6. That's another way to do this. So negative 2 minus the square root of 88 equals, and it gives you this long answer, and then just press divide negative 6, and I'll take that answer and divide it by negative 6, and you get approximately 1 and 9/10. So those are your two solutions. I do think it's important that I make note for you how to solve this as an exact answer. So if we're going to go from here and we want exact answer instead of rounding, you would have to simplify your negative 88, the square root of 88. So square root of 88 equals the square root of 4 times the square root of 22. So that simplifies to 2 root 22. So we would have negative 2 plus or minus 2 root 22 over negative 6. And this still would need to be simplified further because the negative 2, the 2, and the negative 6 are all divisible by 2. So we'd have negative 1 plus or minus the square root of 22 all over negative 3. And that would be your simplified version as an exact answer. Okay, for example 2, we have a graph. It says, and we're modeling with mathematics, it says the number of Northern Rocky Mountain wolf breeding pairs, which is represented by Y, X years since 1990. It can be modeled by the function Y is equal to 2/10 x squared plus 1 and 8/10 x minus 3. When were there about 35 breeding pairs? So the question is asking us, when were there 35 breeding pairs? We need to know, is this 35 representing the X or Y coordinate? When we go back and read the problem, it says the number Y of Northern Rocky Mountain wolf breeding pairs. And then it says X years since 1990. So since we have 35 breeding pairs, that would be our Y coordinate. You could also look at the graph and you'll see that the y-axis is represented by the number of breeding pairs, which we want to know when it's 35, and the x-axis is years since 1990. Okay, so let's rewrite the equation and let's plug 35 into the y-coordinate. So we have 35 is equal to, you can say 2/10 or 20/100 x squared plus 1 and 8/10 x minus 3. And to solve this, to use the quadratic formula, you need to make your equation equal to 0. So let's subtract 35 on both sides. 0 is equal to 0 and 20/100 x squared plus 1 and 8/100 x minus 38. And then from here, our A is 2/10 or 20/100. Our B is 1 and 8/10, and our C is negative 38. So now we're going to plug this into the formula. So x is equal to the opposite of b. So negative 1 and 8/10 plus or minus the square root of b squared, so 1 and 8/10 squared, minus 4 AC. So 4 times 20 hundredths times C of negative 38. All over 2A, which is 2 times 20 hundredths. Okay. So we have x is equal to the opposite of 1 and 8 tenths plus or minus the square root. When we square 1 and 8 tenths, we get 3 and 24 hundredths, minus when you do 4 times 20 hundredths times negative 38, we're going to end up with a negative 30.4. So when we're minusing that, minus a negative, I'm just going to write plus 30 and 4 tenths. All over 2 times 20 hundredths gives you 4 tenths. Okay. When we combine those numbers underneath the radical sign, we have negative 1.8 plus or minus the square root, and we get 33 and 64 hundredths all over 4 tenths. So we're not going to simplify this. Obviously, there's a decimal there, so we're just going to take these two numbers and put them into the calculator. We have negative 1 and 8 tenths plus root 33 and 64 hundredths over 4 tenths. And then you'll do the same thing, but you will subtract it. So negative 1 and 8 tenths minus root 33 and 64 hundredths over 4 tenths. So plug those both into the calculator, and what do you get? You should have gotten, and we actually don't need the approximate sign, it equals exactly 10, and it equals exactly negative 19. Now, before you circle those answers and call it a day and say you have your final answer, you need to look at what the question is asking. So it says, when were there about 35 breeding pairs? So the answer is 10 years or negative 19 years. Well, you can't have negative years, so we'll get rid of the negative 19. And then it was 10 years since 1990, because these are the years since 1990. So 1990 plus 10 years gives you the year of 2000. So 35 breeding pairs in the year 2000. Interpreting the discriminant. So your discriminant, remember I said, was just b squared minus 4ac, the radicand, the part under the radical. And if you calculate your discriminant and it is greater than 0, you have two real solutions or two x-intercepts. The reason why you put the word real in there, when you get to Algebra 2, you're going to learn about imaginary numbers. So it's possible you might not have real solutions, but you can have imaginary solutions, okay? If your discriminant is equal to 0, it means you have one real solution. It crosses or hits the x-axis at one spot, so there's one x-intercept. And if your discriminant is less than 0, it means you have no real solutions. It will never hit the x-axis. Okay, so these go a little bit faster. If it asks you to just determine the number of real solutions, it doesn't want to know what they are. They just want to know how many there are. You just use b squared minus 4ac. So our b is 8. So 8 squared minus 4 times our a in this equation right here is 1. And our c is negative 3. So we have 64, and then minus the negative will give us a addition sign. 4 times 1 is 4, times 3 is 12. So we get 76, which is greater than 0, telling us that there are two real solutions. For part B, before you use the discriminant, you must make sure it's equal to 0. So I should write 9x squared minus 6x plus 1 equals 0. And this tells us that our b is negative 6. So the discriminant b squared minus 4 times a is 9 times c is 1. 36 minus 4 times 9 is 36 times 1 is 36. You get 0. 0 is equal to 0. Therefore, there's only one real solution. Go ahead and try this one on your own. Pause the video and then unpause it to check your answer. Okay, so you should have gotten two real solutions. First, you have to make the equation equal to 0. And then when you do b squared minus 4ac, you get 47, which is greater than 0, so 2 real solutions. For the next page, it wants you to find the number of x-intercepts. So we have an equation that is y equals 2x squared plus 3x plus 9. Well, your x-intercepts, remember, is when y equals 0. So if we make this equal to 0, then it's set up nicely to either use the discriminant or solve using the quadratic formula. We don't need to solve it. They're just saying find the number of x-intercepts or solutions. So because of that directions, we just need to use the discriminant, which would be 3 squared minus 4 times 2 times 9. So 9 minus 4 times 2 is 8 times 9 is 72. So you get negative 63. Negative 63 is less than 0. So in this case, we have 0 real solutions, or you could say no real solutions. All right, try the last one on your own. And when you're done, unpause the video, check your answers. And you should end up getting one real solution because 12 squared minus 4 times 1 times 36 is 0. 0 is equal to 0, one real solution. For the remainder of today, you're going to work on IXL. One is determining how many solutions there are, so using the discriminant. The other is solving the quadratic equation using the quadratic formula. Make sure you're practicing using that. So work for 10 minutes total on IXL.